Java Lambda Expressions Explained, the skill that unlocks dreams. Today we will talk about functional interfaces, why lambdas exist, common built-in functional interfaces, as well as real-world usage and examples. So a functional interface is an interface that has exactly one abstract method. This I need to clarify. It has exactly one abstract method, this interface, but it does not mean that it cannot have non-abstract methods. It can have default methods, it can have static methods, but the fact of the matter is an interface, which is a functional interface, has exactly one abstract method. The next thing is that the apt functional interface annotation is required if you are planning to create and implement your own interfaces. The thing is, just like the override annotation, this apt functional interface annotation is not really necessary. However, it acts as a compile time checker. If you try to implement, if you try to add more than one abstract method to a functional interface with this annotation, it will not compile. But if you don't have this annotation, it will still compile. A functional interface represents behavior and action, hence the name functional. And most importantly, it enables Lambda expressions. What is a Lambda expression? It's a concise implementation of a functional interface. The syntax is that you take in a parameter, it could be one or more parameters, and you output a behavior. And I guess, this arrow is where they get the lambda from. It replaces anonymous classes, and it treats behavior as a value. So essentially what a functional interface does, it allows you to pass behavior as a value. It implements behavior as a value. And what Lambda expressions do, it allows you to pass behavior as a parameter. How are they related? How are functional interfaces and lambdas related? Lambdas implement a functional interface. The compiler infers the target type. If you don't have a functional interface, you cannot have a lambda. An example is the runnable. So you have a runnable interface where you output a behavior, which is print and high. Why were lambdas needed? It's because anonymous classes were verbose. Like, look at this comparator. Like here you have a new instance of a class being created, and look at how verbose this is, as opposed to this lambda, which is more streamlined. So you're taking in two parameters, A and B, just as you are here. You're inferring the types here, and you're returning this behavior. It's an implicit return here. So not only were anonymous classes verbose, but they were harder to read. I mean, do you really want to read this thing? And it allows functional programming, where you can pass a behavior as a parameter. And it's the foundations for streams, which I'm probably going to talk about next, but not during this presentation. How's it used in industry? It's used for event handling. It's used to process collections, specifically, using such functional interfaces such as comparator to sort collections. It can be used for concurrency, such as using executors. And it's useful for filtering and validation. Here are some common functional interfaces. There are around 43 built-in functional interfaces in Java. But here are the most common. Here's the consumer. So it takes in a value and outputs some behavior. It does not return anything. Here's a supplier. It doesn't take in anything, but it returns a value. A function, it takes in a certain type and transforms it into another type. A predicate returns a Boolean. It takes in a type and returns a Boolean. So basically returns true, false. And a runnable, no input, no input, output. It just executes behavior. Examples of how it's used: predicates are often used for filtering. Function is used for mapping. Consumer is used for log and printing. Makes sense. Takes in a value, but not, even though it doesn't return anything, you can still log and print to the console or anywhere else you want to print to. And supplier, lazy creation. You don't take in anything, but you return a value. What are the best practices? Please keep these lambdas short if you can, which means avoiding complex logic. If possible, use a method reference. And that's something you can look up yourself. Use meaningful variable names. Key takeaways. Functional interfaces are essentially a contract, just like any other interface. You have to implement the abstract methods of an interface. Functional interfaces are no different. Lambdas are the implementation of that functional interface. They're very common in modern Java, and they are essential for streams. All right, now we are back in our IDE, and we're going to look at an example of a custom functional interface. Now, as you can see here, we have the app functional interface annotation, and we have a public interface called math operation, which essentially has an abstract method called operate, and it takes in two integers. And that operation, when you implement it, it can be an addition, subtraction, multiplication, any kind of math operation. So we have this annotation. Let's see what happens if we try to introduce another abstract method. Because notice there's only one abstract method here. So let's say int multiply. Oh, and thanks to Copilot, this will cause a compilation error because it violates a single abstract method rule. Okay, and here invalid. Math operation is not a functional interface. So let's see what happens if we remove this annotation. See, now it compiles. But let's put things back to where they were. All right, now let's look at another functional interface that's custom made. And the only reason I have this here is to illustrate that you can have other logic within a functional interface. You can have default method and static method, but the key rule is it has to be one single abstract method. That's the key. Now let's move on to our Lambda demo. And as you can see here, we have two implementations of our functional interface. We have an add and a multiply. And the way that you implement these interfaces is you call the operate method here. And for the printer, we're calling the print method. So this is the functional interface with the default method and a static method. So let's see if we can run this. All right, everything works. Okay, let's move on. So let's move on to our built-in functional interfaces. So we have four being demonstrated here. We have a predicate, consumer, supplier, and function. So predicate, what it does is it takes in a value, and it returns whether this is an even number or not. So it returns a Boolean. This consumer, it takes in a value and it returns nothing. However, it's good for printing. The supplier, it doesn't take anything, but it returns a value, in this case, a random number. And then this function, it takes in a string and returns an integer. So it transforms this value from a string to an integer. And notice that the type is inferred here. So let's run this. Okay, so we have a random number. I'm going to run it again. Let's see if we get a different number. All right. Well, we're done. I'm out. Peace. Take care of yourselves.